Alright, this is a review of the real number system. We're going to go through 5 different types of problems. These are the typical problems that you're going to see on the real number system. They're really asking the same kind of information, just in different ways. The most important thing is that if you remember this diagram and how to label it, the smallest box is natural, the next box is whole, the next box is integers, biggest box here is rational, and the side box is irrational. All of these numbers are real. If you remember this diagram, it can help you a lot. If you see a real number system question and you remember how to draw this diagram, draw it. It will help you. Okay? I'll keep coming back to it as we go through the first 2 examples. I really want to compare those two. One is talking about listing all of the words that describe the number. This is talking about listing the best word to describe the number. I'm actually going to work on the right side first because that's a little bit easier. I just need to list one word, the best word that describes that number. 0 is an ideal whole number. The whole numbers really just include 0 and the positive integers. 1, 2, 3, 4, the counting numbers. 2 divided by 9 is 0.2 repeated. That's a repeating decimal, so that's rational. 6 divided by 4 is 4. That's a counting number. That's one of our natural numbers. 45% is not the number 45. We need to change that into a decimal. Standard form of that number is really 0.45. That is a decimal that stops. That is a rational number. This next one also looks like it's a decimal that stops, but negative 16.0 is the exact same thing as just negative 16. That is an integer. It's a counting number with a negative sign. That is an integer. That next one, 2.385. Those 3 dots, that ellipse means that's going on forever. And there is no sort of pattern there, so that's an irrational number. It goes on forever and does not repeat. Anytime you see pi, pretty much it's going to be irrational. If this was pi minus pi, that would give us 0. Or if it was pi divided by pi, that would equal 1. Those are the only 2 examples I can think of that they would give you that would not be irrational, but pretty much if you see pi, it's irrational. All right, 13,445. That is a big number, but it's still just a counting number. We would eventually count to it. That's a natural one. Next one, 4.0625. That is a decimal that stops. That's rational. The square root of 16 is really just the number 4. We talked about that already. That's a natural number. It's one of the counting ones. Natural numbers are the ones that you can count on your hand. Square root of 61. 7 point, I don't care. It's irrational. If we take the square root of a number and we get a decimal, that's irrational. It doesn't even matter what that number is. We have a decimal that stops. Doesn't matter that it's negative. It's got a decimal. It can't be an integer if it has a decimal. And the decimal stops, so that's going to be a rational number. Alright, so each of these is the best word that we have to describe it. It's the smallest group, the smallest subset that will fit into. When we're talking about that section, we're really saying, where does that number fit in? So let's just deal with a couple of these. 0, that first one, that fits into this group the best. That is a whole number. That's the best word to describe that. The next one, 2 divided by 9 is 0.2 repeated. That's a rational number. That's the best word to describe it. It's the group that it would fit in this diagram. The next part of this section on the left, is asking all of the words that can describe it. So let's look at 0. We see that it's in the whole number box. The whole number box is completely contained by the integer box, and it's completely contained by the rational numbers. Anything inside of whole numbers has to be an integer, and it has to also be a rational number. Okay? So anything in a smaller box has to also belong to one of the bigger boxes. So when we list these out, we're going to list whole. That's the first one. It doesn't get into natural numbers. It's not in the smaller box. It's in the bigger boxes, so it's going to go up to integer and rational. The best word to describe it is whole, but we can also use the words integer and rational. And for each of these, we can use the word real. I'm going to write that in for each of these right now so I don't have to do it later, and so I don't forget. Every single number that we have here, or at least that we're going to deal with until high school, is a real number. All right, so that number 2, let's look at our diagram again. That fits into the rational numbers. There's no bigger group than that other than real. It's just rational. That is a rational number, and it's a real number since they're all real. 16 divided by 4, that's going to fit into our smallest group here. That's a natural number, which means it's also whole, it's also an integer, and it's also rational. It is all 4 of them. Anytime it's natural, it has to be all of them. Natural has to be a whole number, and it has to be an integer, and a rational number. 45% is a rational number. Like we saw up here, when it's a rational number, it's just going to be those two. When it's strictly, when the best word to describe it is rational, it's just those two. It's rational and real. Negative 16 is an integer. That's the best word to describe it. If it's in the integer box, it's also in that rational box. So it's an integer, it's rational. It's not a counting number, it's not positive, and it's not 0, so it's not a whole number. All right, so this one's also real. This one was irrational. It can't be anything else. If it's irrational, it can't possibly be anything else. It can't be rational also. It can't be a decimal that goes on forever and doesn't repeat, while also being a decimal that stops or repeats. Now we get down to these two kinds of diagrams that we're going to compare. It's actually the exact same thing that we saw up top. This diagram is asking us the best group that it fits into. This box, this chart kind of thing, is asking us all of the groups that it fits into. Okay? So I'm going to just start by placing these numbers on the left. 15.0 is really just 15. That's a counting number. That is a natural number. Negative 1.5 times 10 to the first. We move the decimal place 1 place to the right. That's a negative 15. That's an integer. %% is the same thing as 0.5. That's a decimal that stops, so that's a rational number. 1.244, also a decimal that stops right there. That is also a rational number. 0.3 repeated, that is a repeating decimal. It doesn't stop, it's going to go on forever, but it does have that repeating bar, so that, again, is rational. The square root of 2 gives me 1.4, doesn't matter. If we're going to get a decimal from a square root, we know that's an irrational number. If you did the square root of 4, you'd get 2. That's not an irrational number. The only time we have irrational numbers is the square root of non-perfect squares. And our last one, 12 divided by 2 is 6. That's just a natural number. That's one of the counting numbers. All right, so when we go over to that chart, let's just do that first one. 15.0, like we said before, that's just 15. We said it was a natural number. If it's a natural number, if it's in this small box, that means it's also got to be in this box, in this box, and this box. It's got to be in the bigger boxes too. That's a whole number, an integer, a rational number, and again, like before, they are all real. I'm going to check that right away. Okay, so on this one we have that number negative 15. We already converted that to negative 15. That's an integer. If it's an integer, if it's in this box, it's in the bigger box. It's also rational. And you can kind of see a trend developing. If you check that box, then you check all 4 of these, because the rational numbers contains all 4 of those. If you check that one, then you check those 3. If you check just this one, then you check that one. If you check this one, rational, it doesn't go the other way. It only goes forwards there. So on this next one, 50%, that's just 0.5, that's rational. We don't go the other way because it's not an integer, it's not a whole number, or its opposite. Same thing on this next one, that's rational. It's just going to be rational. Same thing in the next one. Repeating decimal is rational, just rational. Same kind of thing with irrational numbers. If it's irrational, it can't possibly also make its way into that group. It's just irrational. So 12 divided by 2 is 6. That's natural. If it's natural, it's also the next 3. 1.456 going on forever. Not repeating. There's no repetition there, but it is going on forever. That's an irrational number. The square root of 100 is really just the number 10. That's a natural number. So it's also whole, integer, and rational. Negative 100 is an integer. Since it's negative, it can't possibly be in either of these two. But since it's an integer, it has to also be rational. 0 is the whole number. If it's a whole number, it's an integer, and it's also rational. And 0.16 repeated, that's a repeating bar over that. That means that goes on forever, and that's a rational number. Alright, so here we have some true and false questions. So these are just general statements about the real number system, and you have to decide whether these are true or false. All whole numbers, every single whole number is an integer. That's definitely true. All of these whole numbers, everything inside of here is inside of that bigger box of integers. All natural numbers are rational, same kind of logic. Anything in this box is in the big box of rational numbers. All real numbers are rational. Well, we know that's not true. There's some irrational numbers that are real, but they're definitely not rational, so that one's false. And all irrational numbers are real. That one's true. Every number that we're talking about is a real number. Just realized that went out of order, but shouldn't really make a difference. Number 2, going back to number 2, some irrational numbers are rational. That can't be true. Those definitions are exact opposites. That's false. This is something that doesn't repeat and goes on forever. This is something that repeats or it stops. They have exact opposite definitions. Some integers are whole numbers. Let's try to think of an example. Integer that's also a whole number. Well, 0, 1, 2, 3. All of those work. All of those are integers, and they're definitely also whole numbers. That one's true. There's some of them. No whole numbers are natural numbers. That one's not true. Almost by the exact same example. 1, 2, and 3. Those are some whole numbers, and they are also natural numbers. So that one's false, because there's at least some of these that are in that group. Last one, no integers are irrational. That one's true. There's no number like this, -7, -8. No number like that that's going to be a decimal that goes on forever and doesn't repeat. So that one's true. There's no integers that could be irrational.